Well, hey, it's that time again for one of the updates of my latest build projects. I'm here in the shop, and today, as I'm sure you can tell by the title of the video, we're going to do the assembly of the variable pitch constant speed mechanism. It's kind of interesting. I'm excited to share with you guys what I've put together. I think it's important that you go through this step sort of in an observation mode, because in a lot of, at least fixed-wing pilots that I've tried to explain this to, it's hard for them to wrap their brains around how it works. So as you see it assembled, you get to see more and more about how it works. So it's an involved process, and I think it's important going through it very carefully and thoroughly so they all understand it together. So let's get right started into it. Alright, so the first thing we've got to do here is we've got to sort of disassemble this in stages so you guys get the hand camera today. And so as you can see, we've got our prototype hub here that I need to replace with the aluminum one. Now the aluminum hub I've already drilled and tapped, and I took a wire wheel to break up some of the sandpaper texture material. It's just part of the printing process. So having taken care of that, I also went ahead and removed the grub screws from the plastic hub and put it into the aluminum one just to make sure that it fit and everything was clean. Now when I drilled and tapped these, I did use my 3-in-1 oil just to lubricate and make sure that everything was going to drill and tap true. And then I cleaned it up with some brake cleaner. So first thing I'm going to do is I'm going to set this aside. I've got a Sharpie marker here. Since everything I kind of want to be lined up fairly even, I'm just going to mark this hole with my Sharpie. I'm going to make sure it's nice and marked well, nice and dark down in there. We're going to rotate it around, and we're going to do the other side too. And from there, what we're going to do is we're going to remove the grub screws from the back plate. And we'll do the same thing. Now, as I remove this back plate, what I should also note is this is a Hyperion spinner back plate. It was a 4-inch diameter, which is what I need for the Mustang. The original Mustang spinner is no longer available from Tower. So that's sort of what I just had to do. Now this back plate does spin a little bit without the grub screws in it, so I'm going to try to more or less line these up and then mark those holes as well. And with the back plate, I've also I've taken this collet that I had in my stash that had a little lip on it. And what's nice about the lip is that I was able to drill out the back of the aluminum spinner, and I used a cone-shaped, it was a taper drill, and just removed the material so that I could press this in, and it's literally press fit with my vise from my garage. And it is in there super snug. And I did rough up the aluminum in case in the event of testing that I feel like I need to braze it. So in the event that I do, I can just go ahead and clean that up with some acetone and braze it. And I do have brazing rods. But I don't think that I'm going to need it because it is in there. With that out of the way, see my mark is there, and I'm going to be careful not to rub that with my fingers because there is still some machining oil on the shaft from the manufacturing process. So what I've done is I've unscrewed my push rod from the mechanism. I'm going to remove that, just set that to the side, and then this whole thing just slips right off. Now, with that out of the way, we've got some pretty clear marks on the shaft where I need to grind flat spots. In addition to these, what I also need to do is take my motor. So I'm going to be using the Flight Test Radial 4030 motor. It's a 510 kV. Literally performs on par with the E-Flite Power 60. Slightly different kV, but it handles all the amps. Very, very good performing motor. Got the stator right here with the bearings in there. I have replacement bearings if I need them, but from the beta version that I tested to now, I believe they've upgraded with higher quality bearings. That was a conversation I had with Josh Bixler at Flight Fest 2019. So keep this to the side for now. But with this, I need to get my ruler and I need to measure roughly where this grub screw is so that I can grind a flat spot for it as well. So let me grab that. Alright, so with the ruler we're going to measure, and it looks like we're at about half of a centimeter down to the center. And with the back plate, we're about 1 centimeter from the center of the grub screw. Let's see if we can line this up for the camera. Yeah, it's about 1 centimeter, maybe 3/4. Let's use my eyeball here. I'm gonna say it's about half. So I'm gonna do 1 full centimeter down. And you can grind flat spots that are a little bit oversized. That's fine. So with that lined up, we're going to do 1 centimeter down. Alright, so I have my flat spot for the motor, flat spots for the spinner back plate, and flat spots for the hub assembly. So I'm going to get a cutting wheel on my Dremel tool here, and I'm going to grind some flat spots. Alright, so our flat spots are all ground down now, and we're ready to do some assembly. Now I can go deeper with these flat spots, and some of you will probably say that I probably should, but keep in mind that I am going to be doing a soft startup and shutdown sequence on this motor, so I'm not expecting to over torque this. If I do, then I'm probably going to break something. If I'm going to break something like from a prop strike or something, it's going to happen somewhere in here and not likely to be anything here, but it's just sort of a design your failure point kind of deal. So the first thing that I really want to do, there goes my Allen key, I'm gonna get this pressed all the way down, and I'm gonna get the motor grub screw flat spot lined up with that hole. And I'm going to do that off camera because it's going to be a lot of pounding and whatnot, but yeah, of note, I want to make sure that you understand that I did order these hollow shafts oversized in terms of length, mostly because at the time of ordering it I didn't entirely know what the size I was going to be doing, so yeah, I'm gonna have to end up eventually cutting off a portion of this off the back once it goes through the stators, but we'll get to that in a minute. So let me do that and come back. Alright, so I've pounded in the shaft and it's a pretty snug fit, as it should be. Just put it on my bench vise and parted the vise a little bit and positioned the hole over top of the gap, and then pounded in from the top. And this is hardened steel, so no risk of really warping it or bending it in the process. Just lightly tapping with a smaller hammer, not a big sledge or anything like that. So let's go ahead and get our grub screw. I am gonna use some Loctite on this. Don't worry. This is just for mock-up. Snug it down a little bit. And there we have it. So now we need our smaller grub screws. And it's just easier to install these on the back plate before slipping it on. And again, I will be using Loctite on these as well when the time comes. We're going to slip it down. See? It's... Well, let me back off one of these grub screws and see what's going on here. Yeah, I am not on that flat spot. So I am going to remove this grub screw. I'm going to tap it down a little bit more. Alright, I'll be back. Okay, so we are back, and I had to take the shaft down a little bit and grind off a little bit more because, yeah, I put it in the wrong spot, but that's okay. It was only a couple millimeters off. So grub screw and in, and then the back plate, and let's see, we'll show back plate is up against that flat spot nicely. So we'll tighten this one. Oh yeah, that ain't going nowhere. Alright, so what we can do now is actually we can slip this shaft onto the stator. Beautiful. Alright, so just a little bit of persuasion there. And whoop! There we go. Now, with the spinner on, well, tiny little wobble, we can work that out. I have in my stash over here. So these are collets. So the original securing mechanism wasn't an E-clip. If you haven't seen my review on the flight test radial, you really should, because the back plate mechanism, I can't remember if I showed it. It's right here. So there is a nut that screws in, and then this screws into the shaft, and then this backs out, and that's how you set the space on the shaft. Really cool design. Really makes things a lot easier for replacement. You don't have to worry about C-clips or anything like that. But we're not using that. We're going to use one of these. So I'm going to have to get a collet on here, and then I'm going to have to locate another flat spot and then pull it off the motor and grind that. Alright? So this is what I was talking about before, where I knew this was a bit too long, but I'd rather be safe than sorry. So I'll probably end up cutting it somewhere around here. And how am I going to get that set screw? Tell you what, I can measure it because we have math. So we'll do that. And we're back. Alright, so it took a little bit of finagling. I realized that I couldn't be able to actually set the grub screw without having to carve away this little tiny gap here. And that's just taking out a little piece of aluminum, so that should be fine. And I did get my flat spot ground. Everything's nice and secure. I went ahead and put my hub on, and that is also very secure now. And so the next thing that we need to do is set that aside, and we're going to focus our attention here. So this is the whole assembly, and really what we need to do is focus on the grip arms. So these things need to come completely apart from the hub and from what used to be a swash plate. Now what's different here from normal helicopters is that normally there is a swivel bearing in here. It's a little piece of brass that just sort of pivots around and allows you to do like different angles. You know, it would sit like this, and you know, you'd get the different angles for, you know, forwards, backwards, side to side. But I've replaced it with just a normal bearing that fits inside this. It does come apart. I had to pry it apart here, and then I put some Loctite in here and pressed it back together. So this piece here, this used to be swash plate, does not get modified in any way. This is just going to spin freely, and this piece is 3D printed. I will eventually do this in a more durable plastic. I'll use ABS, because PLA is just going to heat and warp, and there's going to be heat coming off the motor, and I don't want this thing to fall apart. If in testing that I find that it's getting too hot and getting a little unsafe, I will go ahead and get something either machined or 3D printed, or maybe I'll just do some brazing. Not sure yet. That's something down the road, but pretty easy part to take care of. So in the meantime, I'm going to get this apart, and I'm going to show you all the pieces of just one and show you what needs to be done. Alright, so here we are. I've taken the blades off, as you can see here. I'll get to the blades when we get to assembly. But I've just taken this out. Now these are elongated bolts. These are black oxide bolts that I ordered from MasterCard. They're really, really strong, because really what's going to hold on the blade is just that bolt. And that bolt is going to go into here. Okay? So I've drilled and tapped that for M3. And that's going to screw into here. And that's going to swivel like that. Okay? Now, before we do that, before we even think about doing that, we have to take this apart. And we have to thoroughly clean it and thoroughly lubricate it. There are a lot of parts in here. Alright, so for one, we have this brass spacer. It's like a little washer. And then here, there is a bearing. And I'll get that out, but really here's the meat and potatoes in here. So there is something called a thrust washer. So we have another little spacer. That one's not brass, but that one goes on the inside. And then there is this. So in here you can see there is a little indentation. See if I can get that closer. Yeah. There's a little indentation here. And any kind of dirt or debris or dust or metal shavings or anything like that is going to foul up these bearings. So what I have to do is I have to completely clean all of this as clean as possible. I'm going to use a degreaser. I'll use like a kitchen degreaser. You probably use Simple Green if you have that. I've got 409 on hand, but I'll soak them in that, and then I will rinse all of that off with some 91% isopropyl alcohol, and then from there I will completely grease these. I will soak them in grease. I'll take I've got some nitrile gloves, but I'll put some grease on my finger, and I'm going to literally press it into that bearing before I put it back on this bolt and reassemble it and put it back in here. And then I will use thread locker to go into the aluminum. So let me get all of this disassembled, get it all cleaned, and then we'll come back. Alright, and we're back. So I've gone ahead and done my cleaning, and I'm here ready to show you guys. Well, obviously I've never done this before. I've only seen it done. YouTube is a great place. So sort of what I've been doing is there's a front side and a back side. So whatever side you want it to be. So there's like a cup side and a flat side. And I've been taking the cup side and gently holding it with a hemostat and smearing grease in, rotating over, and then sort of tapping it onto one of the grooved shims for it. And then I just sort of hold it there, grab a little more grease, and then smear it in. And I'm using a little bit of parchment paper here, just because it doesn't shed little particulates of paper. You might use wax paper, but I didn't want to risk getting any wax residue on this. So that's why I'm using parchment paper, because it doesn't really have anything. If I had my druthers, being a scientist, we have this wonderful thing in the lab called Kim wipes. And I could use Kim wipes because those are for like cleaning microscope slides and optics and things like that. And it's a fantastic way to avoid having any fibrous residue. Alright, so these are each of my bearings. I am going to grab a bolt. I put them in here so I wouldn't lose them. And I'm just going to put it in there, the whole stack. And then my spacer washer. We're going to slide that whole schmear and set it in my Allen key. And in addition to that, I am going to take a little more of this grease and sort of smack it in there. The cool thing about this is that once you set it into your grip arm, it sort of centers itself because this is circular here. Now inside there's a bearing there and a bearing there. And you can use bearing oil. I've done that. I've added bearing oil to these because that's sort of what helps with the radial. But this bearing, you know, when there's weight on it, that's what sort of helps it to pivot once there's weight from the blade swinging. So push it in, and I'm going to add the spacer. And for now, I'm just going to temporarily put this in here. I'm going to go ahead and clean these threads and the threads of the hub once I'm ready to do my Loctite. And again, that's pretty straightforward. You just add a drop of Loctite and put it in. But on these, what you kind of need to do is by feel, these bolts need to be torqued all the same. Because the tighter you go, the tighter that this swivel is going to be. So it's hard to demonstrate on camera, but like it's kind of tough like that. But when you back it out, just like an eighth of a turn, it's so much looser. So again, you got to do it by feel, and of course you've got to do them all the same. Otherwise, you're not going to have linear motion. And I don't know how you helicopter guys do it, but I'm doing the best I can here. So let's get the rest of them ready, and we'll come back for the Loctite. Alright, so we're back. I managed to get my red thread locker and secure that into each one of these, and they are pivoting nicely, and there's no wobble or play up and down, side to side, all around. It's very firmly in there, but still rotates very freely. There's a little bit of friction, but that's to be expected. These came with Loctite already on them, and by the way, you know, these are Tarot, T-A-R-O-T, Tarot. I'm not sure how you pronounce it, but these are like aftermarket parts for a 450 size heli. And obviously I've taken it apart and put things together and, you know, taken the pieces that I need, specifically that piece. Okay, so we have the 4 pieces there, and it goes on like that. But we're going to take a little bit, well, you know, we can put it on first. We can put it on. So the whole idea here is that there's going to be a little bit of friction of sliding up and down, but there's an inner race of this bearing where it's going to mostly revolve around on the inside pretty easily. Okay, so with that, we're going to put some machine oil. Once I get this all reassembled, we're going to put some machine oil down there to help reduce friction on the sliding motion right there. And that's going to be one of the things that we're going to have to constantly keep an eye on and maintain, just like any other heli part or whatever. So I'm going to get these clipped onto my grip arms and put some oil on the shaft, and I'll be right back. Alright, so that's on. We've got very smooth play and our motion here. And next thing we're going to do is more lubrication. I've preloaded a syringe here with some grease, and I mean, you can pick these syringes up at drugstores or whatever. And what we're going to do is we're going to butt this up here, and we're going to shoot grease, or at least try to shoot grease, all the way up the shaft. And I am looking at the other end. You might want to as well. Oh. There we go. Nice little curlicue coming out the other end. Alright, so we're going to clean that up a little bit. Again, not too worried about this part. So then we're going to take our push rod and we're just going to lightly coat it. Now the reason I'm doing this is if you just coat the rod, it's going to more than likely, most of it's going to rub off when you stick it inside the shaft. So that's why I'm putting it in the shaft first, and then I'm coating the outer shaft, the push rod, because I want the whole thing to be very well lubricated. And I'm going to make a mess, front and back. See? Ooh. I'm going to keep it horizontal, see if I can keep it from oozing all over the place. Well, gonna have to do cleanup. But that's the point. That is very nicely lubricated. That is perfectly silky smooth. And as the engine gets, or the motor gets run and tested, that grease will break down a little bit, become a little more slippery. That threaded end, I'm not on. Threaded end goes into the top piece. And there it is, coming out the top. So now we have very smooth linear motion. And I'm just going to leave some of that grease up there. I'm going to wipe some of this stuff off, but I mean, you guys get the idea. You have to lubricate everything, because keep in mind that this push rod is going to be stationary. It's not going to spin. Okay, that's the whole point that we have this bearing up here. This is going to be stationary, so I'm going to hold this and the base, and then everything else is going to spin. And then the servo connected to the push rod moves in and out like that. Okay, see how that works? So, last part, I'll clean that up later. The last part are these blades. These blades are from Motion RC, and I've modified them. They are actually Spitfire blades for one of their kits. And just to give a little size comparison, each one of these is 7.5 inches long. Usable is about 7 inches. What I've done is I have rounded off this hub. This hub used to be square, like this, but I had to cut some of it in order to stick it into these hubs. And then on top of that, it comes with a centering hole, and then their design you're supposed to put in 2 bolts. But with this, I trimmed them just enough so that they slip in, and I used that center hole as a guide because it lined up perfectly with where I needed it to be. So then when I put on the bolts for the grip arms with their nylock nuts, that's going to clamp down this entire aluminum bar on the whole surface area of this hub. So that's our clamping pressure. I have no reservations about that. It's so strong. It's ridiculous. And really, that now you can see why this piece had to be metal. This has to, because it's holding all of the force from each one of the blades, all the mass as it rotates, and it has to be solid. You have to screw into it. And normally on a two-blade helicopter, inside of the hub there is a steel piece of tube that these bolts screws into. And so it's not just the aluminum hub, there's a piece of steel inside that it's sort of pulling against. And that's why I needed to make this a solid aluminum piece. The 3D printing technology for steel isn't nearly as strong at this point. So that's why I need to do extensive testing. But I am pretty confident that this is going to work, given some of the experience that I have. I know there's going to be naysayers out there, and that's fine. But you know, that's part of the fun too, is learning and trying new things. Anyway, so before I say anything else and bore you to tears any further, let me get this fully assembled and we'll go over it. Alright, well I hope you guys learned a lot from that. It took me a long time to figure things out and to get things just right. Went through 3 or 4 different iterations of the aluminum hub. I went ahead and made a little stand for clamping it in my vise in my garage for doing the run-up test. We don't want this thing to explode everywhere. I've got a basic Turnigy digital Metal Gear Servo. It's more than enough torque for moving this in and out, and obviously mounted the motor to a plate that can be clamped. I do have a FrSky Neuron ESC. The reason I'm using the Neuron ESC is because it gives me telemetry automatically, so like the amount of current that I'm drawing, the RPM, all of that stuff, so I don't need any extra meters or anything, and it feeds it all the way back to my radio. I can put it on my telemetry log as well, so I don't have to necessarily be looking at it right away, and I can just go back and look at the log. So if anything goes wrong, I can be focusing on the safety aspect and not necessarily on getting the numbers that I need in that moment. Obviously, in order to do that, I need my FrSky receiver, and this one does have the smart port so that I can get that telemetry data. It's the Neuron 80 amp, and I'm using a X8R. So that's the setup for the test rig. One thing I want to note though is in just doing a small power-up test to make sure nothing is binding before I clamp this, I did realize that the motion, the twist from the motor, all of the grease that's on the inside of the shaft was holding the rod quite a bit. So I had to, it's kind of hard to see, but I did have to add nuts to the threaded rod on the front and the back, and then tighten those together to keep that from spinning around. Anyway, small change from what you guys saw in assembly. That's fine, but everything else is unchanged, of course. So the next step is going to get this on the bench for you guys and see if we can make this thing hopefully not explode. I'm excited, I'm nervous, and it's going to be a good time. So stick around and let's keep going on this flying work of art.